Hello my dear friends, I welcome back you to my YouTube channel, that is Beginners Chemistry, where you can learn the chemistry in easy manner. In our organic basics, already we have completed what are the basics to be covered before to start the organic. Then after that, how the sigma bond and how the pi bond has been formed. Then how the sp hybridization that is related to the alkyne, and sp2 hybridization that it has been related to the alkene, and the sp3 hybridization that it is related to the alkanes. Now how it will form already I explained very clearly. Now in this lecture we are going to start the general organic chemistry, and from here the lectures will be continue with the following with the IUPAC, isomerism, then after that inductive effect, mesomeric effect, hyperconjugation, then after that hydrocarbon, and it will be continue. Clear? Now let's start our lecture. Now before going to start the organic chemistry, what is the organic chemistry? Organic chemistry is nothing but study of carbon compounds, study of carbon compounds with hydrogen is known as organic chemistry. Clear? The study of carbon compounds with the hydrogen is known as a which one? Organic chemistry. Clear? Now before synthesis of the urea, now organic compounds has been not at all synthesized in the lab, they have said. Every organic compound can be naturally formed, they have said. But there was a scientist called the Polar. The first he has synthesized the one organic compound with the help of one inorganic compound, that is ammonium cyanate. This is a ammonium cyanate. By taking the ammonium cyanate, now when it has been heated, the first organic compound, that is urea, it has been synthesized in the lab. This after that many organic compounds we are seeing in our daily life. Clear? This is the first organic compound that it was been synthesized in the lab. Clear? There was the scientist synthesized this urea, the name called Euler. That's the reason we call it as Euler is a father of organic chemistry. The Euler is a father of organic chemistry, who made your life easy rather than tough. Clear? Now next, now we'll see. Clear? Next we are going to see the properties of organic compounds. Now what is the meaning of properties of organic compound? Now in our general, organic compounds are more than, we know, organic compounds in general, organic compounds are more than the inorganic compounds. Organic compounds are more than the inorganic compounds. Here it is due to catenation property. It is due to catenation property. What is the meaning of the catenation? What is the meaning of the catenation? Self-linkage. Self-linkage with the same type of atom. The same type of atom. Catenation is nothing but linkage of the same type of the atom is known as a catenation. Clear? Now due to that only carbon can form single bond. We know carbon can form the single bond. Now carbon can form the double bond. Clear? Now carbon can form the triple bond. Clear? Now long chain and ring we used to see, right? Due to this self-linkaging property only, carbon can form the single bond, double bond, triple bond. Clear? And long chain and the ring. Clear? in the ring. Clear? Moreover, the carbon compounds can be exist in many isomers. We know right now there was a separate topic called the isomers. Now carbon compounds can exist in many isomers. Carbon compound can exist in many isomers. Now what are the isomers? There was a topic called the isomers. There we will going to study structural, ring, functional, next geometrical. Clear? Now we'll see the how the organic compounds can be written in how many forms. Now here you can see now how to interpret and write the structural formula. Here writing of the structural formula, many of the student they will make mistake and they will get confused and they will think some other complex molecule they have given without knowing the basic of the organic chemistry. Now organic molecule can be written in the 4 different types. One is dotted formula. Clear? Next one is dash formula. One can be written in the condensed form and the another one is a bond line notation. Clear? In the starting as a faculty we used to think that now the organic chemistry has been started, so as a faculty we will be explained in the form of dash line form, or else once you have got acquainted with the organic chemistry, just we will move with the condensed form. From the condensed form it is more easy to write the molecule in the bond line formula. Clear? So if we strengthen and if we identify the molecule, every time writing in the dash line formula, it will get more time and it will take more time to tackle the question. So once we have acquainted with the bond line formula, very less time we can tackle or we can identify the question or we can solve the given question in the exam. Clear? Try to understand or try to acquainted with the bond line formula rather than the dash line or the condensed one. Clear? Now we'll see one by one how to write the one given organic compound in the 4 different manners. Clear? First one we are going to see the dash or structural formula. Dash or the structural formula. See, whenever we are writing the organic compound with the single bond. Now, single bond can be easily rotated. Freely it can rotate. So that's the reason organic compound of the single bond can be written in many types. See, here the atom joined by the single bonds can be rotated relevantly freely with respect to another. If this carbon and this carbon, if it is attached, we can rotate this carbon very freely. Very freely it can rotate. That's the reason the rotation of groups joined by the single bond does not require usually larger amount of the energy. That's the reason it can easily rotate, right? When we rotate, see if this carbon and this carbon it is in this manner. So when I was rotated, now this carbon has came in this manner. Now again when I was rotated, again this carbon has came in this manner. Again when I was rotated, again it has came in this manner. That's the reason whenever I was writing the one organic molecule, I can write in this manner. This is the example of propyl alcohol. Propyl alcohol normally we can express in this manner. One carbon, because one carbon can form 4 bonds. One carbon can form how many bonds? 4 bonds, right? Clear? Here you can see this carbon and one single bond, one sigma bond and one sigma bond and one sigma bond and one sigma bond. And these bonds are covalent bonds, not the ionic. Most of the organic bonds will form the covalent only. Clear? Now here also these bonds are covalent bond. And how to identify the ionic bond and how to identify the covalent bond already I explained very clearly. Now we know, here also I will explain. Now there was a one shortcut to identify the bond between them. It is ionic or the covalent. Most of the cases it is giving success, but some other it is having the exception. It is not giving success because this is experimentally result. For all the molecule, this formula may not be satisfied. See which one? If the electronegativity difference If it is greater than 1.7, that is ionic. If the electronegativity difference, if it is less than 1.7, that is covalent. That is covalent. Now carbon electronegativity is 2.5, hydrogen electronegativity is 2.1. Difference in that will be the less than 1.7, then the bond between them will be the covalent. Clear? That's the reason here the bonds are covalent bonds. Now you see, we can write in this manner, we can write in this manner, we can write in this manner, we can write in this manner. Now what I did, I was rotated, you can see, I was rotated the sigma bond. When I was rotated, now OH has been came here. Again, if I was rotated here, it can be written. So single bond of the carbon and carbon can be easily rotated. So in any manner we can write the molecule. Any manner we can write the molecule. For example, if I was taking, if I was taking the butane, let us assume this is a butane. Done. Clear? In this butane, if I rotate in this manner, if I rotate, I can write in this manner also. I can rotate any of free rotation of the carbon and the carbon. Clear? Next, another type of the formula we can see, that is condensed form. Which one? That is condensed structural formula. In this condensed structural formula, we cannot represent the carbon and hydrogen bond and the carbon bond. Clear? There is no any such type of the bond will be present in that formula. See here, if you take, this is 2-chlorobutane. This is 2-chlorobutane, right? Here the chloro and the 4 carbon, this is the 2-chlorobutane. Now this 2-chlorobutane, see here in this one we have in the dashed line formula carbon and hydrogen and the carbon bond we have represented, but in the condensed form there is no any such type of the bond will be represented. Only we are representing only to show the which one substituent, but the straight chain we have not at all showing any bond between the carbon and hydrogen and the carbon, and this such type of the formula we call it as a which line? Condensed formula. Clear? We can represent in this manner also. We can represent in this manner also. This is also correct, and if you represent in this manner also, it is correct. Now you can see this is isopropyl alcohol. This is a isopropyl alcohol. In this isopropyl alcohol, this is a dashed line formula. Now with the help of this dashed line formula, here we are having condensed form. In this manner also we can represent. In this manner also we can represent. Clear? Now here also this is also correct. This is also correct. Done. Now this is another type of the molecule to be represented. Next we are having bond line notation. See, as a faculty or many of the organic tutors or faculty or the lecturers, they will use the bond line notation because it is very free to write. And if you are acquainted with the initially, it may give somewhat confused to write the which one? Bond line notation. But once if you get acquainted with the bond line notation, it is very easy to write the any organic compound very fastly. See, in this bond line notation, we will never ever and represent the carbon and the hydrogens. We will never and ever will represent the carbon and the hydrogens. Just we will represent the which one? Molecular chain or parent chain sigma bonds only, or parent chain bonds only we will represent. Clear? Now you see here, if I was taken this one, what is this one? This is a 2-chlorobutane. This is condensed form. Which one? This is condensed form. Clear? Now in this condensed form we can represent in this manner also. In the same way, this carbon and hydrogen you just remove. You can see the same condensed formula only. What you do? You just remove this carbon hydrogen. It will give you the bond line notation. Bond line notation means just here what you have to think that here we are having the carbon and carbon valency is 4. Clear? Now here also is one carbon and the carbon valency is 4, and here is also one carbon, and the carbon valency is 4, and the carbon valency is 4. Now here it is a chlorine. Done. Now here you have to think that here we are having the 3 hydrogens. In the exam or in the any question, they will never and ever represent this one. So many of the questions they will give you in the bond line notation only. Bond line notation only. So you have to consider that here we are having the 3 hydrogens. Here we are having the 1 hydrogen because carbon valency is 4. 1 bond, 2 bond, 3 bond and 4. Here 1 and 2. Clear? Here also 1, 2, 3. Clear? Now this is known as a bond line notation. Now you see this one. This is which one? 2-methyl butane. This 2-methyl butane also we can represent in this manner. Clear? Without any carbon and the hydrogens. Carbon and the hydrogens should not be represented in the molecule or in the formula is known as the which one? Bond line notation. Bond line notation. Clear? Now we'll see some other examples of the bond line notations also. See, first one, if cyclic ring they have given. If they have given the cyclic ring. Here this CH2, here the CH2, here the CH2 if they have given. Just you remove this carbon and hydrogens and that will be the formula. This is a cyclobutane. This is a cyclobutane. In the molecular structure, in the molecular model if you see, it will be in this manner. Now this is a which one? Cyclobutane. Cyclobutane, just you remove this carbon and hydrogens. Carbon and hydrogen. This will be the cyclobutane. Just easy to write. Whenever you are writing the cyclobutane, you can see this is a one carbon, this is one carbon, this is one carbon and this is one carbon. Then this carbon 1 sigma, if I take this as a numbering 1, 2, 3, 4. Now you can see this carbon sigma bond and it will be the 2 hydrogens. You can see here 2 hydrogens. Here also 2 hydrogens. Here also 2 hydrogens. Here also 2 hydrogens. So carbon valency has been satisfied. Clear? Next comes to the, if suppose a double bond if they have given. Here double bond and here it will be the methyl group. You can see here this one, this is a one carbon, here it will be the 3 hydrogens. Done. Now here it will be the again another methyl and here it will be the 3 hydrogens. Done. Clear? Here it will be the double bond because this carbon 4 bonds has been done. 1, 2, 3, 4. Next again this one will be the carbon. Again here it will be the sigma bond. Clear? Again here it will be the 2 hydrogens. Again it will be the methyl. Then again it will be the 3 hydrogens here. 3 hydrogens here. Clear? Now this carbon here 1 bond, 2 bond, 3 bond and the another bond will be the, blindly you have to remember that another. If whenever you are counting the bonds in the which one? Bond line notation. See whenever you are counting, if you comes here, done, if you comes in this manner, in this formula, this is allyl alcohol. In this allyl alcohol, if you counting the bonds, whenever you are counting the bonds, for the carbon blindly you have to believe that it can have 4 bonds. Whenever you are counting the bonds for the carbon, if you got to 2 and next minute it should be strike for you that remaining 2 bonds are hydrogen. If they give or they may not give. In the bond line notation they will not give you. Whenever you are counting the which one? Bonds of the carbon, if you got 2 bonds only, then the remaining 2 bonds should be, you have to assume that they are hydrogens with the sigma bond only. Clear? Now you see, here this carbon and this is one carbon and this is one carbon. Done? Now whenever you are counting the valency for this carbon, first carbon, 1 bond, 2 bond. Then at the same time, the remaining carbon should be satisfied 4 bonds, right? Then blindly you have to believe that and the remaining 2 bonds are the hydrogens. Remaining 2 bonds are hydrogen. Now comes to this carbon. Here 1 bond, 2 bond and this is 3 bond. And the remaining bond will be the hydrogen. Blindly you have to believe. Next comes to this carbon. Here 1 bond, 2 bond. Now for the valency 2 bonds are left. Then the remaining will be the hydrogens. Remaining will be the hydrogens. Now oxygen. Oxygen will form the how many bonds? 2 bonds. Here 1 sigma bond it has been formed and another sigma bond it has been formed. Clear? Now oxygen to complete its octet. How many electrons it should have in its shell? 8 valency electrons it should have. Clear? Already it is 1 here, here 2, here 3, here 4. And the remaining 4 electrons will be which one? lone pair of electrons. This lone pair of electrons also will play very crucial role. In the questions, they will never and ever they will give you the lone pair of electrons on the oxygen. Oxygen, it contains 2 lone pair of electron, and they will never and ever they will give you on the nitrogen. Nitrogen, it will contain how many? It will contain 1 lone pair of electron. Clear? And the sulfur also, it will contain 2 lone pair of electron or 1 lone pair of electron, depending upon the bonds it formed. Depending upon the bonds it will formed. It is a very crucial role to identifying the lone pair of electrons on the atom. Many of the students, they will make mistake without identifying the lone pair of the electrons on the atom. Carbon does not contain lone pair. Clear? Carbon will form the 4 bond, but when it has taken the, when it is behaving as a carbanion, that negative charge will take it as a lone pair. That will consider it as a lone pair. But next, oxygen will have the how many? 2. Nitrogen will have the, sorry, oxygen will have the 2, nitrogen will have the 1. Clear? Then in that manner, chlorine, it will have the 3. Fluorine also, it will have the 3. So identifying of the lone pair of electrons is very important, and it is a key point. Then next, just now we have studied the which one? Condensed formula, dash line notation, and the bond line notation. Clear? Now we'll do some questions based on this one. What you can write the each of the following condensed structural formulas as bond line formula. They have given this condensed formula. They are asking us to write in bond line formula. First one, A. This is CH3 2 times they have given. So you should not get confused. What is that it means? CH3 2 times. Here CH, CH2, CH3. This is 1 carbon CH. This is CH2 carbon. Now this is a CH3 carbon. Clear? Done. Now here the 2 CH3 they have given. 2 CH3 they have given. Clear? Now this is a bond line notation. This is a bond line notation. In this manner, it will be the A. Now comes to the B. B bond line notation will be here this carbon 1. Now next one CH2, this carbon. Next one, this is a CH2. Next one, this will be the OH. This will be the OH. And we are having the 2 CH3, right? 2 CH3. We can write in this manner. 2 CH3. Here 1 CH3, here 1 CH3. What does it mean? This CH3 2 times of this carbon, what does it mean? Means for this carbon only 2 methyl groups are attached. 2 methyl groups are attached. Don't get confused. By seeing this notation also, some of the students they may feel something else. Nothing else. See, this carbon should satisfy how many bonds? 4 bonds, right? Now you see, this carbon, here the hydrogen, and here the 1 methyl carbon, and here the 1 methyl carbon, and here it is a bond. So this carbon has been satisfied the 4 bonds, right? That's it. Clear? It is mean that these 2 CH3s are attached to the 1 carbon only. Now comes to here C. Now C, the bond line notation will be C double bond, sorry. Now this carbon, consider this is this carbon. Now this carbon and this carbon double bond. Done. And the next carbon, this is a CH2 carbon, and the next is a CH3 carbon. Now you see, and the 2 carbons are attached. See, this carbon should satisfy the 4 bonds, right? Already 2 has been done here. Remaining will be here 1 methyl, 1 methyl. That's it. This is the bond line notation of the C. Clear? Next, I will explain G, and the remaining D, E, F and H you try it from your own, or else if you want to do the comment in the comment section also, if you want. Clear? Now G I will explain. G will be the, how first here it will be the CH3, then it will be the carbon. Here this is a carbon, and this is a double bond O. Then next will be the CH2, next will be the CH2, next will be the CH2, next will be the carbon, next will be the carbon. But we can write, actually we should not write in this manner. Now this is a actual correct bond line notation. Just to make you to understand, I was striking the carbons here. Clear? Now this is a bond line notation for the which one? G. Done. Now next we will move to the three dimensionally we can represent the which one? Molecular formula also. three-dimensionally how to represent the molecule. Now here you can see I was taking the example of ethane. Now this is a ethane. You can see this is a hydrogen, hydrogen, hydrogen. Now this is a dash line formula, right? Now whenever for this dash line formula of the ethane in three-dimensionally how to represent? Three-dimensionally we can represent the one wedge notation. This solid line or this one we represent it as a which one? Wedge notation. This we call it as a wedge notation. And here you can see some dotted notation also they have given. This dotted notation and this solid line, see it is there, right? For the one carbon, if you take it for the best example, I will take one slide. See, for the carbon I will take. Carbon maximum valency is 4. Best example I will take it for the methane only. Done? Now this carbon we can represent this methane in the three-dimensionally. How to represent? Now one with the solid line, sorry, one with the wedge notation. This is a wedge notation and one with the dotted notation. Clear? And the remaining two will be the solid lines. Clear? And two will be the solid lines. What does it mean? This, what does this wedge notation represent? See, if you take any one plane if you take, clear? Now you can see in this manner. This is this hydrogen, one hydrogen. This is one hydrogen. Now this is two hydrogen. This is two hydrogen. Now this pen is towards you. This pen is towards you. So this wedge notation hydrogen is towards you. You can see. Clear? Now dotted notation is exactly backward to it. Exactly backward to it. See exactly this hydrogen are you seeing? This hydrogen are you seeing? No, right? Exactly backward to its dotted notation. Clear? In three-dimensionally, if you want to represent the molecule, one will be in the wedge notation towards the observer and one will be the dotted notation away from the observer and these two will be in the in plane and these two will be in the in plane. Now you can see one will be towards the observer, one will be the away from the observer. One will be towards the observer, one will be the away from the observer and these two will be in the in plane and these two will be in the in plane. Clear? Done? Now these are the some examples for the which one of the three-dimensionally how to represent the formulas. How to represent the formulas. Clear? In this manner we can represent. See you can see here one time here the bromo has been in the solid line. One time here the bromo has been in the dotted line. Clear? Now one time you can see the OH in the wedge notation. One time the OH is in the which notation? Dotted notation. Clear? Based on this we will do some question. Now what is asking? Write the three-dimensionally wedge dashed, wedge and dash and wedge and line representation of the each of the following is asking. So one time he is asking for this CH3, this is a carbon. One time he is asking the wedge and dash. Wedge and dash means this chlorine should be in the wedge and the remaining hydrogen, one hydrogen will be in the dotted and the another hydrogen will be in the solids. Clear? Next he is asking one time it will be in the dashed or dotted. Clear? Now another hydrogen will be in the solid and another hydrogen will be in the wedge. Clear? Another time he is asking wedge line. Wedge line means chlorine should be in the line and the hydrogen should be in the wedge and the remaining hydrogen, one hydrogen will be in the dotted and the another hydrogen will be in the solid. Clear? Now this is the representation of the which one? Wedge dashed and the wedge line representation of the each of the following. I was explained for this one, right? And the remaining you can try it from your own. Remaining you can try it from your own. Done? Now before going to start the organic chemistry, how to represent the molecule? How to represent the molecule? We can represent the molecule in the four form. One is dash line notation, condensed form, and one is a bond line notation, and one will be the wedge notation or 3D, three-dimensional formula we can represent. Now, before going to start the organic chemistry, some application towards the organic chemistry we need. What are the some application towards the, actually this will have to be remember while you are solving the questions. While you are solving the questions, these applications will play very crucial role. What are the, already this application you know, but once again I will explain very clearly. Now listen. Here, first one, opposite charges attract. You know, positive charge and the negative charge will be attract, and same charges will be repel. Same charges will be repel. Clear? Now, opposite charges attract, like charges repel. Next, these 2 points are very important in our entire organic chemistry. Every molecule or atom or compound want to try to attain the noble gas electronic configuration to feel the stability. Means what it is saying, nature tends towards state of lower potential energy. So sir, what does it mean? Sir, we did not understand. I will explain very clearly. Now you see. So what I was saying, every atom or every compound want to try to attain the noble gas electronic configuration, or else they want to be in the lower energy state, or they want to be in the lower energy state. Sir, what does it mean, lower energy state? You see, best example already we have studied in our, which one? In the atomic structure. This is a nucleus. For this nucleus, this is n is equal to 1 orbit. This is n is equal to 2 orbit. Now this is n is equal to 3 orbit. Now this is n is equal to 4 orbit. Now this energy of an orbit, total energy of an this orbit, there was a one formula we have given, that is minus 13.6 into z square by n square electron volt. This is the formula they have given. Clear? For the hydrogen like atom, now for that we know this is the one type of the formula we are having. This orbit, this energy, first orbit, it is having the lower energy of minus 13.6 electron volt, right? Done. Second orbit, we are having the approx minus 13.6 by 4. Approx it will give you 3.4. Done. It will give you the minus 3.4 electron volt. See, as the orbit number is increasing, energy of the orbit will be increased. See, minus 13.6 and minus 3.4, which is having the higher number? Minus 3.4 will be the higher number, right? Means if the electron is in the ground state, then how this electron will be excited to the n is equal to 2 state? Means here n is equal to 1 state. This n is equal to 1 state we call it as a ground state. This is ground state. If the electron is in the ground state, by absorbing the energy, electron will be excited to the higher energy state. This is excited state or higher energy state. Why I was saying it as a higher energy state? Because before the electron is in the minus 13.6 lower energy. When it has absorbed the energy, it has been excited to the higher excited state, which is having the higher energy of minus 3.4. Means this n is equal to 1. If the electron is in the ground state, by absorbing the plus 10.2 energy, electron has been excited to the n is equal to 2 state. Before, electron is in the lower energy state. Every electron want to be in the lower energy state to feel the stability. By giving some energy, electron has went to the higher energy state. Higher energy state, why it will be stable? You can say. Clear? Now, that's the reason at the higher energy state, electron will be unstable. Every electron want to be attained and it reach to the lower energy state only. Clear? When it comes to this point, towards the lower potential energy only, it will try to attain to the lower potential energy only. Clear? Many of the electrons want to be near to the 1s orbital. Clear? In our organic chemistry, electrons want to be nearer to the which orbital? 1s orbital. Why the electron want to be nearer to the 1s orbital? Because for the 1s orbital, it is lower energy. s orbital can accommodate to 2 electrons. S orbital can accommodate 2 electrons. Now this s orbital energy is minus 13.6 and it is having the 2 electron. Electron is negative charge and the nucleus s orbital, one s orbital is nearer to the nucleus, right, and its distance is minus 0.529 angstroms, right, minus 0.529 angstrom, very less distance, and this electron and the positive charge will be have some attraction. Clear? Now due to that it will be stable, clear? Is it clear? Because why the electron want to be in the 1s orbital? To feel the stability or to have the lower potential energy, or else every element want to attain the noble gas electronic configuration to complete its octet. Clear? This point is very important. So the term stability we are keep on repeatedly using in our entire organic chemistry. Clear? Next, orbital overlaps stabilize the molecule. What is the orbital overlap stabilize the molecule? Means this chlorine, normally valency electrons of the chlorine is 7. Now this chlorine valency electrons are 7. Done. Now this chlorine to complete its octet, it require 1 electron. It will mutually share 1 electron from the another chlorine. Now this chlorine, it will share the 1 electron from the another chlorine. Now in this manner it will form the which one? Covalent bond, right? In this manner mutually sharing of the electron leads to give the covalent bond. Done. Leads to give the covalent bond. This is Cl2. Clear? Orbitals overlaps leads to stabilize the molecule. See, now this chlorine octet has been completed by sharing 1 electron. Total 8 electrons are there. This chlorine also, by taking the 1 electron, octet has been completed. Clear? Done. Now which of the following ions possess the electronic configuration of the noble gases? So ions or atoms or compounds want to try to attain the noble gas electronic configuration, right? Now you see, first one, A, whether it is possessing the noble gas electronic configuration or not. Na plus. So my dear friends, in our chemistry, this plus indicates that cation, loss of electron. Clear? Now negative indicates that anion, gain of electron. Clear? Remember this one. Na plus indicates that one sodium, one loss of 1 electron leads to give the 10 electron. 10 electron indicates that this is neon electronic configuration, noble gas. F plus. Normally fluorine will have the 9 electrons. By loss of 1 electron it has reached to the 8 electrons. So it has not reached to the noble gas electronic configuration. Next to Ca plus 2. Plus 2 indicates that loss of 2 electrons. Normally the calcium atomic number is 20. By loss of 2 electrons it leads to 18. 18 electron means argon. Argon means it has been satisfied. Clear? Now O minus 2 indicates that gain of 2 electrons. Gain of 2 electrons indicates that which one? Now atomic number of oxygen is 8. By gaining of 2 electrons it has reached to the 10 electrons. 10 electrons means neon electronic configuration. Clear? This 4 I was explained, and remaining this 4 you just try it from your own and you just answer the comment in the comment sections. We'll see hybridizations of the, already we have studied about the hybridization. Now just some basic that we are going to start. Hybridizations of the organic compound. This hybridizations of the organic compounds also will play very crucial role in the application part. Now hybridization of the organic compounds. First one, if suppose I was given one molecule like this, bond line, I will go with the bond line notation. Done? Clear? Now I was written the 4 compounds. Now each carbon hybridization I need. Already I explained one shortcut, or already I explained one formula. What? hybridization number for the organic molecule will be equal to number of sigma bonds plus number of lone pairs. Number of sigma bonds plus number of lone pairs. Done. If the number of sigma bonds plus number of lone pair, if the hybridization number, if it is which one? 4, that is sp3. If it is 3, that is sp2. If it is 2, that is sp. Done. Now we'll see. This carbon hybridization is sp3. How, sir? Now you see. Here this carbon already explained. Carbon will have the 4 valency. Carbon will form the 4 bonds. So whenever you are counting the carbon bonds, if you got 1 and the remaining 3 will be the hydrogen with a sigma bond, already I explained. This carbon is getting only 1 bond. Means blindly you have to believe that remaining 3 will be the hydrogen with the sigma bond. So 1 sigma, 2 sigma, 3 sigma, and this is 4 sigma. Hybridization number 4 with a 0 lone pair. So hybridization number 4 will be this one, hybridization is sp3. Now comes here this carbon. Whenever you are counting the bonds, you got the 2 bonds and the remaining 2 bonds are less for the valency, right? Then you have to consider that those are the 2 hydrogens with 2 sigma bonds. Here the 1 hydrogen, here the 1 hydrogen, 4 sigma bond. This is sp3. Done. Now comes to this carbon. This carbon, whenever you are counting the carbon bonds, you got the 1, here 2, here 3, here 4. Clear? But what I said, you have to consider only sigma bonds. These 2 are the pi bonds, right? The triple bond already explained. Triple bond, 1 sigma bond will be there, 2 pi bonds will be there. For the 1 triple bond, 1 sigma and 2 pi. So you have to consider for 1 sigma and this is 2 sigma. Then this carbon hybridization will be sp, because number of sigma bonds are 2. Number of sigma bonds 2 means sp. Comes to this carbon. This is sigma and this is sigma. Hybridization number sp. Now here this carbon sp3, because here the hydrogen, here the hydrogen. Now here the 3 hydrogens. Here this will be the sp3. Now here all the carbons are which hybridization? sp3 hybridization only, because all are single bonds. Here the 2 hydrogens, here the 2 hydrogens, here the 3 hydrogens. Now comes here. Here this is sp3, this is sp2, this is sp2, this is sp3. Sir, how this is sp2? Already I said 1, 2, 3. 3 bonds you got, and the remaining leftover bond will be the hydrogen with a sigma bond. Done? Hydrogen with sigma bond. Done? Here 1 sigma, 2 sigma, 3 sigma. This is pi bond. Pi bond should not be count. Clear? 1, 2, 3. 3 sigma bonds and 0 lone pair. Hybridization number 3, sp2. Now, here it will play very crucial role and you will get confused. So, if I ask what is the hybridization of this oxygen? Oxygen hybridization is sp3. Sir, how it is sp3, sir? Now listen. Here, this oxygen, it is having 1 sigma bond, 2 sigma bond. Sir, number of sigma bonds 2. Then hybridization should be the sp. Then how we are saying it as a sp3, sir? Sir, you know, right? Oxygen will have the 2 lone pair of electrons. That's the reason they will never and ever they will give you in the question. So here oxygen will have the 2 lone pair of electrons. They will never and ever they will give you in the question. So you have to consider this 2 oxygens lone pair also. So 2 sigma bonds and 2 lone pair. Total it will be the 4 and the hybridization will be the sp3. Clear? Now in this manner the hybridization of the organic compounds we can find. Next calculation of sigma and pi bonds of organic compounds. For the organic compounds, how to identify the sigma and the pi bonds? Clear? Now identifying of the sigma and the pi bond. First example I was taking general example. I will take one this one and the next benzene, best example for you. Benzene will be the well-known compound for you. Next will be the here And the next type of the compound I was going to take clear. And one very tough or very easy for you I was taking clear. Done. Now how many sigma, how many pi bonds are there in this, you have to identify. Here this is very important. Many of the students, they will make very much mistake in the hurry. They will, whenever the bond line notation they have given, they will ask you how many sigma and how many pi bonds are there in the given following compound, they will ask. So many of the time the students, they will forget the hydrogens. Whatever the bonds they are seeing in the structure, they will consider, and that many bonds. See, whenever you are counting this one, how many sigma bonds you will get, 1, 2, 3, 4. Only the 4 sigma bonds you got, and 2 pi bonds you got. So the option, first option will be 4 comma 2 will be there. So you will see 4 and 2, and you will pick this A and you will come, but the answer will become wrong. Then after that you will see, oh my god, sir, why it has become wrong? Because the carbon, it is having the 4 valency, each carbon it is having the hydrogens. You will forget this one. So now the total number of sigma bonds for this one will be the 1, 2, 3, 4, 5, 6, 7, 8. Total 8 sigma bonds and 2 pi bonds. When it comes to the benzene, it is having the how many sigma bonds? If it is asked for the benzene, directly you will see 1, 2, 3, 4, 5, 6. 6 sigma and 3 pi. First option will be, or second option will be this one, you will pick and you will come, and again it will become wrong. Why? Because here this carbon, if you count the bonds, how many you are getting? 1, 2 and 1 pi bond, 3 only you are getting, and the remaining will be the hydrogen with the sigma bond, right? So you have to count this hydrogen with the sigma bond also. Now in this manner benzene will be there. Total sigma bonds for the benzene will be 12 and 3 pi bonds will be there. Done. Now here how many sigma bonds are there for this one? Here this carbon, if you counting, you are getting only 2 bonds, and the remaining 2 will be the hydrogens with the sigma bond, already I said. So here 1 sigma, 2 sigma, here 3 sigma. Done. 1 sigma, 2 sigma, 3 sigma. Now here this carbon 1, 2, 3 bonds added, and the remaining will be the 1 sigma with hydrogen. So 1 sigma bond, 2 sigma bond, 3, 4, here 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 sigma and 1 pi. Now here I will explain this compound. Now how many sigma bonds and how many pi bonds are there for this D molecule? You just comment in the comment section. I will explain for this compound. So 1, now here, now if suppose if they have given this nitrile, or you may know it as a cyanide, right? But this secondary suffix or functional group name for this one will be the nitrite. So whenever this type of the compound they have given, blindly you will believe that the number of sigma bonds will be for this one 1, 2, 3, 4, 5 sigma bonds, and pi bond will be the 1 pi bond, you will think, and you will come. But here this compound will be in this manner. Here this carbon, normally carbon should have how many bonds? 4 bonds. Nitrogen will form how many bonds? 3 bonds. So this will be the triple bond end, right? Clear? Now this is a carbon and with the triple bond end, because nitrogen will form the 3 bonds, carbon will form the 4 bonds. Carbon with 4 bonds, its valency satisfied, octet complete. Nitrogen with 3 bonds, and the remaining will be its lone pair of electron. Now this nitrogen octet has also completed. Done. Here also its octet has been completed. Now here when it comes to this carbon, now here with the 3 hydrogens. Now here with the carbon with the nitrogen. Done. Clear? You can see this is sigma, 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 and this is sigma. and this is sigma. Total how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma. 9 sigma. And how many pi? You can see here this is 1 pi, 2, 3, 4, here 5, here 6, here 7, here 8, here 9. Total 9 sigma and 9 pi. 9 sigma and 9 pi. Clear? Done? Now, next we are going to see the degree of carbon. Now, what is the meaning of the degree of carbon? So, degree of carbon means, what is the meaning of the degree of the carbon? Means, here for this carbon, if it is attached, if it is attached with only one carbon, this carbon is attached with the only one carbon, right? So, this carbon we call it as a 1 degree carbon. This carbon we call it as a 1 degree carbon. Clear? Next. Again, I was extending its carbon chain. So, this carbon is attached with the 2 carbons, right? This carbon is attached with the 2 carbons. So, this carbon we call it as a 2 degree carbon. Done? Next, I will extend this carbon and I will write another carbon here. Done? Clear? Now, this carbon is attached with the 3 other carbons, right? Here, this carbon has been attached with the 1 carbon, 2 carbon, 3 carbon. So, this carbon we call it as a 3 degree carbon. This carbon we call it as a 3 degree carbon. Clear? Now, again I will extend this carbon in this manner. Clear? Now, you see, this carbon has been attached with the 4 other carbons, 1, 2, 3, and this is 4. So, this we call it as a 4 degree carbon. 4 degree carbon. If the carbon attached with the 4 different carbons or 4 carbons, quaternary carbon. If carbon attached with the 3 carbons, tertiary carbon. If carbon attached with the 2 carbons, secondary carbon. And if the carbon attached with the 1 carbon, primary carbon. And this is also attached with the 1 carbon, right? So, primary carbon. This is also primary carbon. This is also primary carbon. And this is also primary carbon. Clear? Now, they will give you the one molecule. If suppose if they have given in this manner. In this molecule, how many 1 degree carbons are there? How many 2 degree carbons are there? How many 3 degree and how many 4 degree carbons are there? Now we have to see. This is 1 degree carbon because it has attached with the 1 carbon. Now this is 2 degree carbon because it has attached with the 2 carbons. Now this is 4 degree carbon because it has attached with the 4 carbons. 1, 2, 3, 4. Now this is 1 degree. Now this is 2 degree. Now this is 1 degree. Now this is 2 degree. Now this is 1 degree. Clear? Now this is 2 degree. Clear? Now this is a degree of the carbon. Next we are going to see degree of hydrogens. Next we are going to see the degree of hydrogen. For the degree of hydrogen, you have to be very careful with the degree of hydrogen. 4 degree hydrogen is not possible. Only 1 degree hydrogen, 2 degree hydrogen and 3 degree hydrogen only possible. 4 degree hydrogen it is not at all possible. 4 degree hydrogen it is not at all possible. Why? Because best example you take before one only, swastik. Done? Now, here this carbon, it is having the 3 hydrogens. It is having the 3 hydrogens, right? Done? Here you can see these hydrogens are attached to the 1 degree carbon. These hydrogens are attached with the 1 degree carbon because this is 1 degree carbon. So, these hydrogens are also called as a 1 degree hydrogen. Now, this is 2 degree carbon. Now, these are 2 degree hydrogens. Clear? Better I will take another example here. Like this. Okay. Now, here you can see, here also one hydrogen will be there. Now, this is 3 degree carbon. This is 3 degree carbon. So, this hydrogen is 3 degree hydrogen. But 4 degree hydrogen it is not possible. Why? Carbon valency is 4. Already this carbon is attached with the 4 other carbons. Why it will take the extra hydrogen? No, right? So that's the reason 4 degree heterogeneity is not at all possible. Done. Next one. Next one, degree of alcohols. Degree of alcohol. What is the degree of the alcohol? If the alcohol functional group, if it is attached with the one carbon, if CH3, CH2, OH, if they have given, this alcohol functional group is attached to the one carbon, so this is 1 degree alcohol. Next one, CH3, CH, OH and OH. CH3, CH3, CH, CH3 and OH. This alcohol is attached to the 2 degree carbon. So this is 2 degree alcohol. Next, CH3, CH3, this is OH and this is CH3. Now this OH is attached to the 3 degree carbon. So this is 3 degree alcohol. This is 3 degree alcohol. Clear? Now you can see here. Here the OH, here the OH, here the OH if it is given. Now this is which one? 1 degree alcohol. This is 1 degree alcohol because it has attached with the only one carbon. Now this one is a 2 degree alcohol because it has attached with the 2 carbons, and this is 1 degree alcohol. 1 degree alcohol. Next we are going to see the which one? Degree of amines. Degree of amines will play very crucial role. Degree of amines. So what is the meaning of degree of amines? Here the degree of amines will play very crucial role and it will make you confused. It will make you confused. For the alcohol, directly it will be attached to the carbon. That attached degree of the carbon will say it as a 1 degree alcohol, 2 degree alcohol and the 3 degree alcohol. But here when it comes to the degree of amine, if CH3, CH2, NH2, done. This which one? Nitrogen has been attached to the one carbon, so this is 1 degree amine. This is 1 degree amine. Now you see CH3, here the N, H, here the CH3. Because nitrogen can form the 3 bonds and it is having the lone pair of electron. Nitrogen valency has been done. See, nitrogen 4 valency octet has been completed. Here 1, 2, 3, 4, 5, 6, 7, 8. So it has been attached with the 2 carbon atoms. This is 2 degree amine. Now 3 degree amine will be this is 3 degree amine because it has attached with the 3 carbons. Clear? Now in this manner the degree of amines we can say. Done. Next one. Next we are having bond length. Already I explained you very clearly in the which one? In the basics how the bond length will be formed. See, when the 2 atoms are when they are overlapping from this nucleus of one atom and this nucleus of one atom, nucleus of one atom and this nucleus of one atom, this length we call it as a bond length. Here they are forming the stable bond, right? Here due to this overlapping they are forming the bond, and distance between that bond we call it as a bond length. Distance between that bond we call it as a bond length. What is the definition of bond length? Average distance between center of nuclei of 2 bonded atoms. Clear? Now bond length order, this is very important. Bond length order. If they ask in which case bond length is I, so single bond is having the higher bond length, next double bond, next is a triple bond, Clear? Sometimes in the questions they may ask what is the bond length, between, see already we know this is alkane, or we can represent it as a which one? Ethane. Done. Next one we are having this one, it is a alkene. This one it is a alkene. Next one we are having the triple bond. This is alkyne. They may or they may not. They may or they may not. But try to remember this one. This carbon and this carbon bond length is 1.54 angstroms. 1.54 angstrom. And this carbon bond length will be 1.34 angstroms. Clear? And this carbon bond length will be 1.29 angstroms. Done? And this carbon hybridization is sp3. So sp3 carbon and hydrogen bond length will be 1.120 angstroms. Clear? Now this carbon hybridization is sp2. sp2 and this carbon hydrogens bond length will be 1.103 angstroms. Clear? Now this carbon, it is a sp. This sp and this hydrogen bond length will be 1.08 angstroms. 1.08 angstrom. Clear? Many of the cases they may or they may not, but just you try to remember. Clear? Next one, the next another basic concept that we are going to study, it is a bond energy. What is the meaning of the bond energy? Energy required to break the bond. Energy required to break the bond is known as a bond energy. Clear? The bond energy is inversely proportional to the bond length. Energy required to break. Energy required to break the bond. Energy required to break the bond. Clear? If bond length is high, if the bond length is high, bond energy is less. With the very less energy, we can break the bond. So bond energy order will be triple bond first, next double bond, next will be the single bond. Single bond. Clear? Now these are the some bond energies we are having. Done? Now here next point you have to remember, if carbon, this is sp3 and hydrogen, this bond energy is less, than carbon sp2 hydrogen, next carbon sp hydrogen. Clear? Now this is a bond energies required to break. Next very most important that we are going to study, that is polar and non-polar. So how to identify the polar and the non-polar? To identify the polar and the non-polar, polar means if the dipole moment, if it is not equal to 0, that is polar. If dipole moment is equal to 0, that is non-polar. Polar means dipole moment should not be equal to 0. Non-polar means dipole moment should be equal to 0. Clear? Or else, if you are getting confused, remember in this manner. Difference in electronegativity, if it is not equal to 0, that is polar. If the difference in electronegativity, if it is equal to 0, that is non-polar. Already I explained you in the basics how to remember the electronegativity values also. Highest is a fluorine, from the fluorine to lithium decrease a 0.5. Done. HF, if I take, HF is polar or non-polar? Electronegativity value is 4, electronegativity value is 2.1, difference is not 0. So this compound is polar. Done. Or else you can say with the electronegativity also. Fluorine is a more electronegative. It will pull the bond pair of electron towards itself. When it is pulling the bond pair of electron towards itself, fluorine will get the partial negative charge, hydrogen will get the partial positive charge. Due to that polarity also, this is polar. Now, which is a non-polar? Comes to the H2. H2, H and H will form the covalent bond. Electronegativity is 2.1, difference is 0. So, homodiatomic molecules are non-polar. Example, H2, O2, N2, H2, O2, N2. These are the non-polar molecules. Clear? And some examples for the polar and non-polar molecules. First, dipole moment if it is, or polar molecules, we'll see. Polar molecules means dipole moment not equal to 0. Example, that is H2O is a polar molecule, H2S is a polar molecule, HCl is a polar molecule. Clear? Now CH3Cl is a polar molecule. Clear? NH3 is a polar molecule, HF is a polar molecule, HBr is a polar molecule, HI is a polar molecule, acetic acid is a polar molecule. Clear? Now alcohol is a polar molecule. Clear? Now these are the polar molecule. Done? Now dipole moment is directly proportional to the electronegativity. Clear? If the electronegativity increases, dipole moment increases. Clear? Next, non-polar molecules. Non-polar. What is the meaning of the non-polar molecules? Mu is equal to 0. Example for the non-polar is H2, N2, O2, Cl2, CH4, BH3, BF3, CO2. Clear? Carbon disulfide. Clear? And this is transalkene, and the next is a transalkene. Clear? Now these are the dipole moment is 0. Dipole moment is 0. Clear? Next. Now by this we have completed the basic. From the next class we will start the classification of the organic compound. How the organic compounds has been classified. One is a open chain and one is a closed chain. Clear? After that I will see the IUPAC and followed by the lecture. Now we will meet in the next lecture.